Assalamualaikum to Puan Suzanawati. Ladies and gentlemen, my name is Nur Shafina binti Salman. My matrix number is 11 DKA 19F 2005. I am the third presenter for today.
I am Nojiha binti Muhammad Nazri, 11 DKA 19F 2008.
I am Muhammad Alif Najmi bin Redwan, 11 DKA 19F 2012 as a first presenter.
Hello, my name is Muhammad Shukri bin Jamuri from DKA 3A. My matric number is 1119F 2013. So I'm second presenter.
Okay, the content in this presentation we have 6, which is objective, theory, apparatus, procedure, conclusion and discussion. The objective is to determine the CBR value for a soil under consideration as a pavement foundation. This value is a percentage comparison with the standard crush road from California. Theory, it is important to realize that the CBR test is one step in the road pavement foundation design process. The test load the road engineer to design the capping layer and the sub-base layer by determining the strength of the underlying soil. Engineer can determine if this strength is adequate to enter the desired road design, or if additional procedure need to be done to increase this strength. Okay, we have 7 apparatus for this experiment, which is loading machine, measuring cylinder, steel, CBR mold, Search Wick scale, tree, and last but not least, sample soil.
So there is 5 procedures in this presentation. Number 1, the soil was crushed by using a hammer. After that, the soil was sieved by using 20mm sieve. Number 2, the soil sample was weighed. Number 3, the soil was mixed and divided by 5. Number 4, the weight and the mold and put with the rub and the mold with a grease. And lastly, number 5, place the first portion of soil into the mold and compact it with 65 number of blow by using 4.5 kg rammer and 50 diameter. So the process was repeated until 5 layers are done. Next, remove the collar, trim and the soil flush with the top of the mold with a scraper and the weight the mold with a soil.
There is 8 procedure using CBR machine. So the first procedure is place the mold with the base plate containing the sample with the top face of the sample exposed centrally on the lower plate of the testing machine. Then place the appropriate annular surcharge disc on the top of the sample. Fit into the place of the cylindrical plug for the measuring for the force measuring device assembly with the face of the plug resting on the surface of the sample. Make sure that the proving ring die gauge is properly adjusted, that there is no daylight between the bottom of the stem and the proving anvil. Apply the seating force to the plunger. Then record the reading of the force measuring device as the initial 0 reading or reset the force measuring to read 0. Secure the penetration die gauge in position. Record its initial 0 reading or reset it to read 0. Make sure that all connections between plug, crosshead, proving reel and penetration die gauge assembly are tight. Start the testing of the plunger penetration. The sample of the uniform rate of 1 plus minus 0.2 mm over mean, and at the same instant start the timer. Record the reading of the force gauge at interval penetrations of 0.25 mm to a total penetration at not exceeding 7.0 mm. So discussion about this presentation is, according to this graph result, it is not a very smooth curve of the plot graph. Therefore, adjustment of the graph should be done in the order to have a more accurate result. Also, there is a difference between a standard CBR value and the initial and the experimental value. The possible curve error are listed as below. So, my friend Najiha will continue this discussion.
Firstly, its air void appears in the soil. In reality, honestly, the volume of the air cannot be negated. No matter how the compaction is perfect, the air void still exists. Moreover, the size of the aggregate is different. The gap between the aggregate becomes wide. Therefore, the effect of the air void in the experiment cannot be determined correctly and hence affect the result. Second, chemical compositions of aggregate to the soil since there is mineral contents in the soil for such quartz, plegoclase, microclines. The minerals are relatively stiffer than others. Then the stiffness and the strength of the soil will change. It is chemical compositions of the aggregate to the soil that cannot be determined. Thus, the result is affected. Moreover, the standards of the CBR value used in laboratory is the British standard. As the soil is different everywhere in the world, the characteristics of the soil is also different. Therefore, the value of the soil is different from the experimental result since the soil used is not the same type. Solution for this experiment is in the experiment we finally found that the CBR value of soil in 2.5 mm and 5 mm are 2.5 and 4.5 respectively. Generally, the CBR value at 2.5 mm penetration will be greater than that at 5 mm penetration, and in such case takes the value at 2.5 mm as the CBR value. If the CBR value corresponding to a penetration of 5.0 mm exceeds that of 2.5 mm, we need to repeat the test. In this case, the value is acceptable.
Thank you for your cooperation. That's all from us.